Alright, so just to get started, we're gonna just kind of do a really simple example, just to sort of just give you an idea of what a problem looks like, a really simple problem, and to show the associated model. And what I want you to do is kind of look at both of these scenarios. And what I also want you to do is kind of look at the scenario, kind of just understand it, and also look at some of the look at the model as well as so you can kind of just see what's going on. So I'm just kind of just fixing my screen a bit, and then we'll continue on. So you've got a toy company each that produces wooden trains and soldiers, and they use wood, take some labor hours, and it sells for profit. And in general, you kind of want to be able to maximize the profit. So, but with the example here, I've got a couple of questions that I want you to think about when you're looking at them, just so that you can start making some connections. So, one of the first questions would be, what does max stand for? So, in the bottom slide, we got max at the bottom, and I kind of just said it already. We want to maximize profit. So, I want you to think about how the profit is represented here with 3t plus 2. Where does the 3 come from? Where does the 2 come from? And you should be able to answer that in your head pretty quickly. So, and in the more general version, the next question I've got written here is, where do the numbers in the example appear in the model? So it's like, say you've got 1 kilogram of wood, 1 kilogram of wood here, but where are the ones in the model down here? Once again, we've got 7 hours to produce. We've got 4 hours to produce. We can see a 7 and a 4 here. So what does that tell you about that third equation? And then I want you to do the same for, like, say, the 11 kilograms of the wood to produce labor hours. You can see that on the right hand side here. What does that tell you about the equations in the model? So I want you to have a think about that one as well. And that actually leads me to my third question as to what you think each equation represents. And I think you're kind of starting to get an idea now. And within the equations as well, you can see that they are inequalities. So in this case, they're less than or greater than. So again, this relates to the question of what the equations represent and what do you think they are trying to describe. Lastly, at the bottom of the model, we have S and T greater than or equal to 0. If you didn't read this little blurb where you say, let T be the number of trains produced, and let S be the number of soldiers produced, so you can kind of just think you're saying, okay, the number of soldiers produced must be greater than or equal to 0, and the number of trains produced must be greater than or equal to 0. Now, while you're kind of just brewing this over, I do want to point out that in linear programming models, in LP models in general, usually we have this first function, and then we have this little phrase such that. So the such that is just kind of just I guess the correct way to write a model, because say we want to max something such that something something something, and what it's sort of like when you read it out is how it works. However, for brevity, or like some future models will kind of just shorten that to, like, say st, or they like s.st to stand for such that, or they may leave it out entirely. So it's kind of just to make things a bit easier to read, but just for the sake of readability, some people leave it in, some leave it out. Doesn't really matter. So have a think about the scenario, have a think about the model, and then once you're ready, I'll see you on the next video.